Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. This video is about sizing the firefighting pump. How to economically select a fire pump. Okay, so let's assume that after I finish my hydraulic calculation, the system need is 1000 GPM. See, the system after hydraulic calculation, after hydraulic calculation, we get, it means the system needs 1000 GPM at rate of 100 psi. Okay, that. So how we will select the pump economically? Okay, we should be very careful when selecting pump to meet the system demand, and also the pressure should not be less than required system pressure and not exceed the rating of the system pipes and fitting which is installed at the churn pressure. Okay, see, generally we install 250 psi or 300 psi, the rating of the fittings and pipes. So the system also should not exceed that one rating pressure at the churn pressure. Churn pressure, it means 140% on zero flow is called churn pressure. So on that one pressure, the pressure should not be exceed the fitting and pipes. Okay, now that, so we all know the 3 points that the fire pump must meet as per the NFPA 20. First 100% flow. Okay, at rate of 100% pressure. Okay, second condition as per NFPA is zero flow. Okay, at rate of maximum 140% churn pressure. (140% churn pressure). Okay, the condition third is 150% flow at minimum 65% pressure. Okay, then this is the 3 conditions we should keep in our mind when selecting the firefighting pump. Okay, after hydraulic calculation. See, this 3 point is mentioned in NFPA 20. Okay, and see, as per NFPA, which I mentioned that 150% of the rated flow. You can stop the video and can read as per NFPA, but I already mentioned there. Okay, here. So select the flow. Don't select after hydraulic calculation you get the 1000 GPM at rate of 100 psi. So don't select that 1000 GPM at rate of 100 psi pump. Okay, it's not a wrong selection, but you could have saved some money. Okay. How? Let's start. Okay, so this is the limit. We all know the limit of the selecting fire pump should be system demand should be false. Okay, let's just write here system demands false between 90% to 150%. Okay, okay, so this is our limit, 150%, less than 150%. Okay, so what the GPM we required? 1000 GPM. So here 1000 GPM divide 1.5. okay, it means 150%, less than 150%, that's why I divide, otherwise we have to multiply if it will be mentioned more than 150%. So I divide 150%. okay, that. So we will get, when we will divide, 66.67 GPM. okay, here, but as per NFPA fire pump rating, here fire pump rating, there is no any 66.6 GPM fire pump rating. okay, so we will select next one. Which one is next? Here 500, after that 750. So we will select here 750 GPM pump. okay, so we will select here 750 GPM pump. okay, what about pressure? For here pressure we required is 100 psi. okay, so we will check that on 750 GPM, or firstly we should convert this one as percentage, that here the system falls between 90% to 150%. So we have to check that it's falls between 90% to 150% or not. okay, as per NFPA. So is equal to what we required, 1000 GPM, but we select 750 GPM pump. So what the percentage? 133%. okay, so the system, the pump which I select 750 GPM falls between 90% to 150%. it means 133%. okay, so it's good as per NFPA. So we can select this, we can select the 750 GPM pump. okay, this one 750 GPM pump we select. But what about the pressure? okay, so we will check the performance curve of the pump at 750 GPM. okay, so to select the pressure we have to check the performance curve of the pump, that at 133 percentage flow, how much the pressure? It shall be around 78%, but how? See, here I downloaded one catalog for making this video. So this is the performance curve. We have to select the at 750 GPM. Here, suppose here 750 GPM at this one the head pressure. Okay, so we don't know what is the head pressure because we are just calculating. Okay, so we don't have the efficiency curve, performance curve to select the pump. Okay, so if we don't have the performance curve, we will use this formula, this one formula. Okay, y, it means y is the pressure. Okay, here you can read pressure created by the pump in percentage and minus 0.7x plus 170. Okay, here you can write here minus y is equal to minus 0.7x plus 170. This is the formula. X represent that percentage of the demand. Okay, what is the percentage of demand here? Here is equal to minus 0.7 multiply x. What is the percentage demand? 133%. 133%. Okay, plus 170. Okay, so what will be if we calculate 0.7 into 133 is 93.1 minus 170. It means that it's near about 78%. Okay, or 77%. You can take 78. Suppose 78. Okay, 78%. Here 78%. Okay, so next is if we calculate the percentage of performance 78%, so how much we required? 100 psi we required. Okay, 100, and what is the percentage of the performance? 78. It means 0.78, right? So what will be if you divide, then what will be the outcomes? 120. Okay, 120 psi. So our final result is 750 GPM at rate of 128 psi. We will order the pump. Okay, this much demand we will order. We required, after hydraulic calculation, we got 1000 GPM at rate of 100 psi. So we cannot select that 1000 GPM at rate of 100 psi because it will be more cost. It's not wrong, but it will be more cost. So we can save some money. So we will calculate as per the NFPA, because NFPA is already give some allowances, like we can select the pump between 90% to 150%. So we have to take the advantage that one. Okay, and select the pump. So finally we got the 750 GPM at rate of 120 psi. This is the formula. If we don't have the pump performance curve, to select the efficiency of the pump, so we will use that one formula. Okay, this formula we will use to calculate the percentage of the pump, and after calculating we will divide what is the percentage will come, and finally we will get the pump. Okay, so here 750 GPM at rate of 128 psi. Okay, and after that 750 GPM pump, then here we can select 6 inch will be suction, 6 inch will be discharge, and whatever that one relief valve and relief discharge valve here already given. Okay, so reduce the flow and get little higher pressure anyway. Okay, anyway your material in this case up to 250 psi. The fittings and pipes we install in the firefighting system is almost 250 psi. So our pump here selected 120, here 128 psi. So it's enough, it's very good. Okay, so this is the selection of pump economically. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.